Okay, we're going to go over the Unit 4 study guide. If you look at the first question, you're looking at three objects, a sphere, a cone, and a cylinder. And you're looking for which one has a rectangular cross section. So if we cut each shape, if we cut a sphere vertically, and we cut it all the way around, that's going to give us a circle. If we cut it horizontally, you can see the circle here. So a sphere will not work. If we cut a cone, we cut it horizontally or parallel to the base, we're going to get a circle. If we cut it vertically, then we get a triangle. In the cylinder, if we cut it horizontally, we get a circle. Or if we cut it vertically, then we're going to get a square or a rectangle. Okay, so the cylinder is the only one that will allow us to have a rectangular cross section. Number 2, you're looking for which one has the greatest area. Okay, so I have to find the area of each of these shapes. This shape is a triangle, so I'm going to use my area formula for a triangle, which is base times height divided by 2. So I'm going to fill in my measurements. The base of my triangle is 20. The height of my triangle is 8. And then I'm going to divide that by 2. 20 times 8 is 160. And then when I divide that by 2, I get 80 inches squared for the area of Kármán sine. For heat sine, this is a complex shape here. So I'm going to divide it into two different shapes. So if I extend this line down, then I get a triangle and a rectangle. So to find the area of my triangle, I'm going to do base times height divided by 2 again. The base of my triangle is a flat side. So this flat side here from top to bottom measures 10 inches, and that comes from here. The height is the vertical distance, okay, from the top down. So this has to be a straight line. These lines are slanted, so they can't be a height. Height has to be straight up and down. So the distance of this line is 8, and then I'm going to divide that by 2. So 10 times 8 is 80, and then 80 divided by 2 is 40 inches squared. So the area of just this triangle is 40 inches squared. The square, or the rectangle here, the area is length times width. The length of this rectangle is from here to here, and that is 8 inches. And the width is this side, which is 4 inches. And 8 times 4 is 32 inches squared. So to find the total area of heat sine, I need to add these two together. So my area would be 32 plus 40, which is 72 inches squared. So this one's 72, this one's 80. So we want to find the one with the greatest area, so that would be Kármán sine. So the sine that Kármán found has a greater area. Okay, if we look at number 3, Steve says the formula to calculate the volume of the prism is V equals B times H, where B is the area of the base, okay? So the area of the base times the height is the formula that Steve is going to use, okay? Well, the area of the base I have to find from this prism. Well, this prism is a triangular prism, so this triangle here is the base of that prism. So to find the area, or to find the area of a triangle, I do base times height divided by 2. That gives me my big B. And then I can multiply that by the H from the height, okay, of the prism. Well, I don't have a base and a height. I have a length and a width instead. Base and height and length and width are the same thing, okay? So I can replace base and height with length and width, divide it by 2, and then multiply it by the height of the prism. So this is Steve's way here. Okay, now Anton says the formula is 1/2 length times width times height. Okay, well, if I take half of the length and the width, here's my length and the width, I multiply those together and take half of it, then that's the same as dividing it by 2. Multiplying something by 1/2 is the same as dividing it by 2, and then I'll multiply that number by the height. So Anton is also correct. So who is correct? They are both correct. And they're both correct because they both find the area of the base first, then multiply it by the height. Okay, and that's the height of the whole prism, so from one base to another base. So if the width is 2 centimeters and the length is 3 centimeters and the height is 3.5 centimeters, it wants us to find the volume of the prism. Okay, so I can take either one of these formulas, this one here or Anton's here, and I can plug in the numbers that I'm given, and I'm going to find the volume. Okay, so if the width was 2, that means instead of W, I have a 2. Instead of the length, I have a 3. And instead of the height here, I have 3.5 centimeters. Okay, so then I can take those numbers and put them inside of my formula. So if I use length times width divided by 2 times the height, then my length is 3, my width is 2, and I'm cutting these numbers from here. Length is 3, width is 2, and divide that by 2 and multiply it by the height, which is 3.5. Okay, so then 3 times 2 gives me 6, divided by 2 is 3. So 3 times 3.5, my volume equals 10.5 centimeters cubed. Or if you want to use Anton's formula, volume equals 1/2 length times width times height. You just plug in those numbers. 1/2 times my length, which was 3, times the width, which was 2, times the height, which was 3.5. And when you multiply all those together, you also get 10.5 centimeters cubed. So either formula I use is going to give me the same answer, and it should, because I said up here that they're both correct. So if they're both correct, then it's both going to give me the same answer. If you look at number 4, Sophia makes and sells stuffed toys. She uses a special fabric to cover a foam cube to make a letter block. Well, she's covering it. That means I need to find surface area. I want to know out there the whole outside of this cube here. We want to figure out how much fabric did Sophia use to make this block. Okay, well, the cube is made up of squares, and we know a square has the same measures on all sides. So if the length is 8 centimeters, then the width is also going to be 8 centimeters. So now that I have my length and my width, I can find the area of my square. So my length is 8, my width is 8. I multiply those together and I get 64 centimeters squared. Now that's just the area for the front side of my block. Now a cube here has 6 sides. So if I take that 64 and multiply it by 6, and I'm multiplying it by 6 because that's the amount of sides that the cube has, then I get 384 centimeters squared, which is B. Okay, for number 5, On a scale drawing, the height of a tree is 2 and 25/100 inches. If the scale of the drawing is 1 inch to 75 feet, how tall is the tree? Anytime I see anything about a scale, then I know I need to set up a proportion. So I need to figure out what two things I'm comparing. And in this problem, I see that I'm comparing inches to feet. So those are my two things. I can write it out in words first, so I make sure I have everything in the correct position. So then if I'm given a scale, that's going to be my first fraction. So I'm going to have 1 over 75 equals, and then I use whatever other information I'm given. And I'm given 2 and 25/100 inches. So I'm going to use that number, and since it's inches, inches go on top. So I place it here on top. I'm looking for the amount of feet. I don't know that, so I get a variable. Then I'm going to cross multiply to solve this proportion. 1 times x is x. And then when I multiply 75 times 2 and 25/100, I'm left with 168 and 75/100. Now, if you notice in my problem, I have two answers with 168 and 75/100, C and D both. One is in feet, one is in inches. Okay, well, I'm missing my bottom number, which is feet. So that makes C my correct answer. And then if you look at part B, it says that the same tree is shown as 5 inches tall in a new scale drawing. What is the new scale? Okay, so again, I'm talking about scale. So I'm going to have a proportion. I'm doing inches to feet again. Okay, so my new scale is 1 inch to some number. Okay, so I'm going to have 1 over, I don't know what my scale is going to be. I don't have any information here, so I put a variable. That's going to equal, my other information that I know is that it's 5 inches tall on this scale, so 5 goes on top because it's inches. Now I need the feet down here on the bottom. Okay, the feet that I know comes from part A. Okay, it is 168 and 75 feet. That tree is not going to change sizes no matter whatever scale I use. If I go measure that tree outside, it's still going to be 168 and 75/100 feet tall, no matter if I'm using this scale or a new one that I'm going to create here. So you do the same thing and cross multiply. 5 times x is 5x. And then 168 and 75/100 times 1 is 168 and 75/100. Okay, this time I have a coefficient with my variable. So I'm going to get rid of that by dividing both sides by 5. Solve that one-step equation there. And then when I divide that by 5, I get 33 and 75/100. Okay, now notice I'm missing my bottom number here, and on bottom my units are feet. So this would be 33 and 75/100 feet, and make sure that is included there because when you're given a scale, you're measuring in two different units, and you have to have both of those units. Number 6, it tells me that the measure of angle AFB is 64 degrees. So that's this angle here, and it measures 64 degrees. Okay, we need to name an angle that's complementary to angle AFB. Okay, complementary angles. What's special about complementary angles is they have a sum of 90 degrees. It's two angles that when I add them together, I get 90 degrees. Okay, so complementary angles have a sum of 90 degrees. So a 90-degree angle is a right angle. So if I look at angle AFB, I need to put another angle with it to make a right angle. Okay, that would be angle BFC. So angle AFB and angle BFC are complementary angles. They both join together to form this right angle here, which is 90 degrees. So I need to find the measure of angle BFC. Okay, well, if they're complementary, that means they make a right angle together. So if this one is 64 degrees and together they're 90 degrees, then I can take 64 and subtract it from 90 degrees. And when I do that, I'm left with 26. So the measure of this angle is 26 degrees. My next type of angle is I need to name an angle that is supplementary to angle AFB. Well, supplementary angles are special because they have a sum of 180 degrees. Okay, so that's also known as a straight angle, which is a straight line. So I need to make a straight line out of angle AFB. Well, from here down is my straight line. AFD is my straight line. So I'm going to use my first angle plus another angle to give me a straight line. Okay, so that means I have all of this space here to fill in with an angle. So if I look at what letters I connected, it's B, and then my vertex is F, and then this line here is D. So my angle would be BFD as my angle. So it would be angle BFD. And since this one is supplementary, they have to add up to 180 degrees. Well, if this one is 64, then I can take 180, subtract 64 from it, and then I'm left with 116. So that angle BFD, is 116 degrees. That's this small angle and then this one combined together. It's 116 degrees. Now, if I'm looking at an angle that is vertical to angle AFB, okay, I need to find an angle that's vertical. Something special about vertical angles is that they have the same measurement. So that means I can take my angle and I can flip it on top of another angle and it's going to be exactly the same. So if I took angle AFV and I flipped it over, if I took this angle and I just flipped it over backwards, then it would land here, which is angle EFD. So angle EFD would be that angle. And we just wrote that vertical angles have the same measure, so the measure of that angle is also 64 degrees. Okay, if we look at number 7, the volume of the barn. Okay, we see that our base here of a barn is a pentagon. Well, I can't find the volume, or I can't find the area of a pentagon. Okay, and we have to have volume, we have to have area for our volume formula because we have to find the area of the base times the height. Well, my base is a pentagon, so I'm going to split it up into shapes I can find the area of. So that would be a triangle and a rectangle. Okay, so to find the area of my triangle, do base times height divided by 2. The base of my triangle here is 12 feet. The height of my triangle from top to bottom. Okay, I'm not given that, so I have to find it. I know that the whole barn from top to bottom is 19 feet. Okay, that's where this comes from. And I know that from the bottom up to this point is 9 feet. So if I subtract 19 minus 9, then I'm left with the height of my triangle here. So 19 minus 9 leaves me with 10. Oh, hang on, got blurry. Okay, so my height is 10, and then I'm going to divide that by 2. So 12 times 10 is 120, divided by 2 is 60. So I get 60 feet squared from a triangle. Okay, now my bottom shape is a rectangle. So to find the area of a rectangle, I do length times width. The length of my rectangle is 12 and the width is 9. 12 times 9 is 108 feet squared. So to find the total area of my pentagon here, I need to add these two areas together. So my area at the base would be 60 plus 108, and then times the height. Now height goes from base to base, okay? So from base to base, the distance between those two would be 35 feet. So I multiply that by 35. You can put 60 plus 108 in parentheses, multiply it by 35 in your calculator just like that. You could add these together first. So that gives you 168 times 35. It doesn't matter which way you do it there. You're going to come up with the same answer either way. So you're going to get 5,880 feet cubed. Okay, so you get 5,880 cubic feet. Now the surface area of a barn, to find that, you're going to find the area of each one of the sides. And you can break it down with front, back, left, right, and top, left. And you can make a chart from that. So you have the front and back, you have left and right, and then you have top, left, and top right. Now my front and back, I've already found the area of it. 60 plus 108 is 168. So there's two of those, a front and a back. My left side and my right side are rectangles. This is my left and right side here. And this rectangle measures 35 long by 9 high. And then the area of that, 35 times 9, is 315. Then my top left and my top right are also rectangles. They're here, top left and top right. Okay, and the measurements of those rectangles is 35 by 11.7. So I'd multiply those two together. That gives me 409 and 5/10. So to find my surface area, I'd add all these together. Both of my 168s, both of my 315s, and both of my 409 and 5/10. Okay, and all together, if I put that in my calculator, 168 plus 168 plus 315 plus 315 plus 409 and 5/10 plus 409 and 5/10 gives me 1,785. Now this is in feet and it's squared because it's area. So 1,785 square feet would be the surface area of this barn. Okay, let's look at number 8. Okay, number 8 says a triangle has two sides with lengths 8 centimeters and 15 centimeters. So the first part says which of the following lengths could represent the length of the third side. So you're going to write 8 and 15 beside each one of these answer choices. You're going to circle the two smallest numbers and add those together and see if they are greater than your largest number. If it works, then it is a triangle. If it does not, then it's not a triangle. So if you add 6 and 8, you get 14. And then you say, is 14 greater than 15? That's not true, so that's not a triangle. So you're going to do the same thing for B, C, D, and E. Right, 8 and 15 beside each one. and circle your two smallest numbers and add them together. So if they're greater than your greatest side. If you come across one that's equal, it still doesn't work because they're not the same. One has to be greater than the other. So in this one, it'd be 10 and 8. 10 plus 8 is 18. 18 is greater than 15. So this would be a triangle. This one would be 14 and 8. 14 and 8 is greater than 15. 14 and 8 is 22. That's greater than 15, so that's a triangle. Then the next two are 8 and 15. That has to be greater than 23. 8 plus 15 is 23, and 23 is not greater than 23, so that one does not work. It's not a triangle. Okay, part B says, how many possible triangles could you draw if the angle between the two known sides was also given? So if I had a triangle and I had a number here and a number here, and then just an angle measure. For example, we could make this a right angle. It would be 90 degrees. Okay, how many different triangles could I make with this? With these characteristics? And my answer is 1. I could only have one triangle. And only one triangle is possible. When two sides and the angle between them are known. And we call this a side angle side relationship. And you'll learn more about that in high school, but you got a side length, an angle measure, and then another side length. And from that given information, you can see if you have a triangle or not, and that would only be one triangle. So for number 9, we have consider the possible cross sections of a square, pyramid, a cylinder, and a cube. Tell whether each of the following statements are true or false. Okay, so these are all my figures here. This one would be the square pyramid. This is a cylinder. And then this one is the cube. So all three figures can be sliced to create a rectangle. Well, a rectangle and a square have the same characteristics. Okay, you got 4 right angles. So a rectangle and a square have the same characteristics for the most part. Rectangle has 4 sides, square has 4 sides. Rectangle has 4 right angles, square has 4 right angles. So if we can make either one out of all of these, then that one would be true. So if we look at A, all 3 can be sliced to create a rectangle / square. If I cut this square pyramid horizontally, then I get a square, so that one works. If I cut the cylinder vertically, then I get a rectangle, so that one works. If I cut a cube any direction here, I can cut it horizontally or vertically, then I'm going to get a square, so that one works also, so that one is true. For B, the pyramid and the cube have the same shape cross section when sliced perpendicular to the base. Okay, perpendicular to the base means I'm going to slice it vertical, up and down. So the pyramid vertically, if I sliced it vertically, I'd have a triangle. And the cube, if I sliced it vertically, I would have a square or a rectangle. So do they have the same shape? That would be false. Only the pyramid can be sliced in a way that creates a triangle-shaped cross-section. Okay, now if we look at the pyramid, we see the triangle there. Cylinder would be a rectangle, and then horizontally would be a circle. A cube, if we did it vertically or horizontally, would both give us a square. but I could cut off this corner here, and when I cut off that corner, then I could see that shape would be a triangle. So then that one would be false because I have two shapes that would give me a triangle. For D, the greatest number of sides possible for a cross section of one of these figures is 6. Okay. Then this one would be true because I could take and cut every side of this cube and touch every side as I cut it, and it would make a shape. It would actually make a hexagon. And that's kind of hard to draw. And then the hexagon there would go through every side. So that one is true. And that would be true for the cube. For number 10 on the back side, Bill is making donuts by stamping circles in dough using a pastry stamp with a radius of 1/7500 inches. For the donut hole, he stamps out a circle of dough using a pastry stamp with a radius of 2500 inches. Okay, so for part A, it says, what is the area of the donut hole? Use 3.14 for pi. So my area formula for a circle is pi r squared. Okay, so if I'm looking at the area, I'm going to plug in the information that I know from my circle. So area equals pi, which is 3.14, times my radius. The radius we're looking at the donut hole here, so the small circle is 2500, and we're going to square that number. And remember, squared means to multiply it by itself. So we're going to square 2500 first. So I got 3.14 times 0.0625. So 625 10,000ths. And then when I multiply that times 3.14, I get 0.19625. And that is inches squared. Okay, if I look for part B, it says, what is the area of the donut hole without the donut hole dough? Then again, it says use 3.14 for pi. So I'm going to find the area of my large circle first. So I'm going to use the same formula, pi r squared. So that's 3.14 times my radius of my big circle is 1/7500. And I'm going to square that number. So I'm going to do 1.75 squared. That gives me 3.0625. And I'm going to multiply that times 3 and 1400. Okay, so that's the area of the large circle, including the donut hole. But I've got to take out, so I've got to subtract, because it says without the donut hole dough. So I'm going to take out that area, which is 0.19625. So when I subtract those out, that gives me 9 and 42 hundredths inches squared. And then part C says, what is the circumference of the donut hole in terms of pi? So when it says in terms of pi, that means I'm going to leave the pi symbol in my answer. Now I'm finding circumference here, so I'm going to use the circumference formula. So I can use circumference equals 2 times pi times r. R is for my radius. So the circumference of the donut hole would be 2 times pi times my radius, which is 2500. So in this case, I would only multiply 2 times 2 times 2500, which is 5/10. So I get 5/10 pi. And I have to leave that pi symbol in there because it says in terms of pi. And then the last question, number 11. A geologist drew a scale drawing of a section of quartz layer she saw in a cliff. The scale drawing of the layer is 4 centimeters high and 28 centimeters long. The actual layer is 2/10 meters high. What is the area of the actual quartz layer section she saw? So the first thing I'm going to do is I see this as a scale, so I'm going to set up a proportion. Okay, so the scale is 4 centimeters to 28 centimeters. Okay, so if I got 4 centimeters high, so I'm doing how high it is to how long it is, to 28 centimeters long. If the actual layer is 2 meters high, so 2 would go on top, 2/10 would go on top. Okay, I'm looking for the actual length of the quartz layer. So I cross multiply, I get 4x, and then 28 times 2/10 gives me 5 6/10. And that would divide both sides by 4. That would give me 1 4/10. Okay, and that would be meters. All right, now I have to find, it asks for the area. So since I'm finding area, I've got to multiply. It says a section of quartz layer. So that's going to be a rectangle. So I'm going to do length times width. So height times length there, length times width. So I'm going to do 2/10 times the width, which was 1 4/10. And when I multiply those together, that gives me 2800 meters squared. So the area of the quartz layer section is 2800 square meters.